Okay, this is your final section in your grade 9 MathLinks textbook. Hope. We are doing isolating variables and equations that have variables on both sides. So the first question is probably the easiest version of a question you can have. And in order to think about this question, let's draw it first. So 5x is equal to 4x and negative 6, or 4x minus 6. Essentially what you need to consider when you have variables on both sides is you can't have variables on both sides because your goal is to isolate the variable, meaning getting it on one side. Get it on one side. Get it alone on one side. And since it's not alone on one side, we have to figure out how we can do that. So what we have to think about is the basic idea of algebra. The balanced scale is used because whatever you do to one side, if you do the same thing to the other side, you maintain equality. And for the most part in grades 7 and 8, what you've learned how to get rid of is constants and coefficients. However, in this case, what we want to do is we want to think about how do I get rid of an entire term. And in order to get rid of an entire term, I can take these 4x's and remove them. And if I take those 4x's off, and I take these 4x's, which have the same value, I should still maintain equality. Okay, that's the idea of what we do when we have variables on both sides. So in this particular equation, what we're really going to do here is we're going to subtract 4x from both sides. Not dividing by 4, not adding 6, but we're going to subtract the entire term of 4x. And those two things make 0 pairs. Now, subtracting 4x is the same thing as if I was to take these two things down here and get rid of them. It's the same thing as if I was to add negative 4x to both sides. Right? Adding negative 4x and positive 4x would make a 0 pair, just like we put the line through here. Another way to think about subtracting 4x is to add negative 4x, both the same thing. When we do that, going back to chapter 5, a positive 5x and a negative 4x are like terms. It combines just to make an x, which is now isolated. It's an isolated x. And on the other side, we have just a negative 6 left. And therefore, the value of x is negative 6. And what we could do is we can go back into our equation, if we wanted to, and we could substitute that negative 6 for x here, and substitute that negative 6 for x here. And this is negative 30. This is negative 24 take away 6, which is also negative 30. And we have achieved equality when x is negative 6. In the second question, in your next equation, if I was to draw it, a 2x and a positive 1 equals 3x and a negative 4. So if drawing it, if I was to remove 2x from this side and remove 2x from that side, I would create this equation. Numerically, removing 2x from both sides would be 1 equals x minus 4. I would then add 4 to both sides if I was drawing it, or I would add 4 to both sides if I was using numbers. Oh, sorry, I put a line through that. Put a line through that instead. 5 would equal x. Okay. I could go back and check just to make sure I am right. So 2 times 5 is 10, plus 1 is 11. 3 times 5 is 15 minus 4, which is also 11. Your next question, and this is going to be an interesting one to draw, and this might help you see why it's important to do what we do. So those are negative 2x's there, and these are positive 3x's here. Okay? So when we do this, there are different ways we can do it, but what we generally try to do is get rid of the variable on the side that has the least amount. And in this case, the negative 2x is less than the positive 3x. So what we're going to try and do here, JA, is we're going to add 2x to this side, and we're going to add 2x to this side. And in doing so, we create a 0 pair, but what we also create is a much simpler equation of 5 equals 5x. What it looks like over here is adding 2x and adding 2x. So 5 equals 5x. And now when we have that, we're just going to divide both sides by 5 to get rid of the coefficient. And x will equal 1. Okay. Now, just as a side, what we could do, let's pretend for a second that we did actually decide to put this instead. Okay. So what we would have done here is subtract 3x from both sides. Okay. The only difference is when I do that, on this side of the equation, there is nothing left. But on this side, you have a 5, and you have a negative 5x, excuse me. So what that would be is 5 minus 5x equals 0. And if you end up isolating variables and you end up with 0 on one side, it's okay. It just means you have to work a little bit harder to get the answer. So you're like, oh, I screwed up somewhere. Well, now I'm just going to get rid of the constant by subtracting 5. I have negative 5x equals negative 5. Divide both sides by negative 5. And x will still equal the same answer as 1, but you took an extra step because you made the wrong first step. So don't worry about making the wrong first step. As long as you, in algebra, do one thing to one side and do the same thing to the other, you could make 25 steps and eventually get to the right answer. It just means that it's more efficient if you were to get rid of this first as opposed to this. Question 4, we have both variables and constants. So the one we have less of is this one here. Our first step, when you have multiple steps, is to get rid of the variable from one side. So I'm just going to subtract a half of x from this side and subtract a half of x from this side. That's going to leave me with 1.25 equals. Now right here, we have a chapter 5 question. What do you do when you have... So when we combine like terms, adding or subtracting like terms, the variable and the exponents are the same, so we just combine the coefficients. So a positive 1.5 and a negative half would be a positive 1x. And since 1x's or 1 coefficients are unnecessary, we just have an x. X minus 3.75. So by getting rid of the variable on one side, we end up with this fairly easy one-step equation. All we have to do is acknowledge that negative 3.75 is the constant and get rid of it as x, and x equals 5. Question 5 is variables on both sides and there's distributive property. So when you have these types of questions, what I advise you to do is just expand your distributive property first. So 2x minus 2 equals 3x plus 6. What side has the least amount? Well, it's the 2x. So I'm going to subtract 2x from both sides. Negative 2 equals. Combining those two like terms will leave us with a 1x again. And subtracting the constant from both sides will give x equals negative 8. This is Modulus equation using money and algebra tile. So we have, this says 3 groups of x dollars and 20 cents. X amount of money and 20 cents. And this says 2 groups of the same x dollars and 70 cents. And those are going to be the same amount of money. So if I'm drawing it, I'm going to draw an x and a 20 cents. And I'm going to be lazy here and I'm going to infinite clone it. Double it, triple it. So this 3 right here means I have 3 groups of this amount. And on the other side, I have that same x dollars and 70 cents, but I have 2 of them. So these two sides are equal. So 3x's and 60 cents is equal to 2x's and $1.40. So what this really says when I expand it is that 3x's plus 60 cents is the same thing as 2x's and $1.40. Okay, so once we get that, I don't think it says to solve it, but let's solve it anyway. I'm going to subtract 2x from both sides, or subtract those 2 and those 2, leaving me with x is equal to, x plus 60 cents is equal to $1.40. I'm going to subtract 60 cents from both sides. Find out that x equals 80 cents. When I subtract 60 cents from here, I'll subtract 60 cents from there, leave me with a dime extra. X is equal to 80. Now the next question speaks to my which do we have less of. So when you have variables on just one side with no constants or coefficients, sometimes it's easier just to get rid of the other side anyway. But on this side here, this is the least amount of x. So if I subtract 0.25 x from both sides, this can be hard for some people. Half of x take away a quarter of x is going to be still a quarter of x is equal to 1.6. Divide both sides by your coefficient, and x equals $1.60 divided into piles of 25 cents. Let's think that through. $1.60 divided into piles of 25 cents. You can make 4 with $1. You can make 2 more. That's 6. 6 and a bit. 6 and a bit. X equals 6.4. Next question. Now we get into what is the most difficult thing for students to do, and that's fractions and algebraic equations. And when we get to these questions, if you can do it, I advise you strongly to do it. And that's knowing that this is the same thing as 1/3 times x, which is the same thing as x over 3. So if you know that 1/3 x and x divided by 3 or x over 3 are the same thing, then what I advise you to do is before you do this question, rewrite this whole thing like this. Okay? And remember, there are 2 methods you could solve it. There's 2 methods. The first method is to get rid of the constant, then the coefficient, using opposite operation. Right? Get rid of the constant and coefficient using opposite operation. So what that would mean is adding a half to both sides and then multiplying both sides by 3. That's one way to do it. And sometimes in easy equations, it's the best way. Other times, the easiest way to do it when there's fractions is to multiply both sides by a common multiple of the denominators. So in this particular equation, we have a 3, a 2, and a 6 for denominators. So if we multiply both sides by a common multiple of those, sometimes you need to write them out, sometimes you don't. But if I did, I would find that the first multiple that they share is 6. And any multiple will work, but 6 is the lowest, so it's the easiest. So if I take this side and multiply it by 6, and take this side and multiply it by 6, the idea is you're taking an equation, multiplying this side by 6, and this side by 6 maintains equality. But because there are 2 terms here, both must be multiplied by 6. So 6 over 1 multiplied by 6 over 3, x over 3, excuse me. 6 over 1 multiplied by negative 1 over 2. Notice I took the negative symbol and just combined it with the numerator because it is a part of the term still. And x over 6 multiplied by 6 over 1 would be multiplying all of the terms in the equation by 6. You don't have to cross reduce. If you didn't cross reduce, you got 6x over 3. 6x divided by 3 is 2x. If you did cross reduce, you still got 2x anyway. If you don't cross reduce, you get 6 times negative 1 is negative 6 over 2, which is negative 3. If you did cross reduce, you still got negative 3. And over here, if you didn't cross reduce, you got 6x over 6, which is x. If you did cross reduce, you still got x. Now we have an equation that's much simpler than this one was, or at least it looks a lot simpler because it's fraction free. I'm going to subtract x from both sides. And don't worry about, you can subtract 2x from both sides too. I'm just giving you a basic guideline for how to do it so you maintain usually positive coefficients. When you do that, you end up with 0 over here and x minus 3. Add 3 to both sides, and you get x equals a positive 3. Your next question, we get into the easier ones of decimals, and most people have no problem with decimals. Now, if you wanted to, you could do one of two things. Now, this is the side with the least amount of x, and typically I did say to you, get rid of it from the side, but you know that if you add 2.3x to that side, it leaves you with nothing. So in situations where you're going to be left with nothing, you have the option. It saves you a little bit of time. Getting it rid of the side that has x is okay as well, right? So what you would end up with is 7.52 equals negative 5.5x. And this is okay. In fact, it saves you one step because it simplifies your life a little bit, right? Now I'm just going to divide both sides by negative 5.5. And 7.52 divided by 5.5 is, is that the right answer? 1.36, and 72 repeats to infinity. 1.3672, but 72 repeats to infinity is equal to x. Is that positive or negative? It's a negative. Because a positive, negative 7.52 divided by negative 5.5 is a negative. That's your answer for that one. Your next question, again, same thing that we just talked about in the last one. If I add x to both sides, I'm going to be left with 0. Or if I subtract 2.5x from both sides, I'm going to be left with a negative coefficient. So it's up to you. Which one do you want to do? Do you want to subtract 2.5x from both sides or add x from both sides? Subtract. So let's subtract 2.5x from both sides. If we do that, we have negative 3 left on this side. And over here we have negative 3.5x, right? In order to get rid of that, we're going to divide by negative 3.5 to get rid of the multiply coefficient. And over here we're going to divide by negative 3.5. Okay, some people hate this part, but it's not overly difficult. Negative 3 is really negative 3 over 1. Remember, the negative 3.5 is the same thing as negative 7/2. And since dividing by fractions is the best way to tackle it, the most easy or efficient way to do it is to multiply by the reciprocal of the fraction. We're going to multiply that by the reciprocal of negative 3.5, which is negative 2/7. Remember, the reciprocal of a mixed fraction, you have to examine it as an improper fraction, then flip that. Once we have that, we have x isolated because we got rid of the coefficient here. And on the other side, we're going to have a positive 6/7, which is your answer. Next question, what side has the least amount of x? Here we don't have to worry because I know this is the least amount of x, so I'm just going to get rid of it. Creating a zero pair, an algebraic zero pair. 2.6 is equal to 1.5 plus 2.2x. Subtract 1.5 from both sides. 1.1 is equal to 2.2x. Dividez-vous both sides by 2.2. And x equals a half. 1.1 divided by 2.2 is 0.5. Next question. So if you see this and you're like, hey, what did Mr. McDonald say when I have fractions in the equation? Oh yeah, I remember this now. He said when you have this, you should write it like this. When you have this, you should write it like this. And just as an aside, if you have this, you should write it like this. Right, etc., etc. So with that given, if I wanted to rewrite this equation, before I do it, I'm going to rewrite it like this. Now, options. Options are, you can subtract a 6th of x from both sides if you want. Right, if you want. But when I say subtract a 6th of x, you're like, oh, I hate doing that because I hate working with fractions, especially when there's variables in them. So the best solution to do right now would be what? Multiply both sides by? What's the common multiple of 6? What's the denominator in 5? 1, 2, and 1. What's the first common multiple 6, 1, 2, and 1 share? 6. So if I multiply this side by 6 and multiply this side by 6, I'm going to create an equation that is equal, but 6 times larger on both sides. So 6 over 1 times x over 6 is going to be 6x over 6, or just x. 6 over 1 multiplied by negative 5 over 1 is going to be negative 30. 6 over 1 multiplied by x over 2, oh, I made something there, 6 over 1, is going to be 6x over 2, or 3x. And 6 over 1 multiplied by 2 over 1 is 12. Now, I don't know about you, but if I was given a choice between answering this question or this question, I think 1,000 times out of 1,000 I would choose the second, because there is no difficulties in this, no common denominators, no, nothing complicated. Subtracting x from both sides. Negative 30 equals 2x plus 12. Subtract 12 from both sides. Negative 42 equals 2x. Divide both sides by 2, and x will equal. Let's go somewhere where I have some space. X will equal negative 21, or negative 21 equals x. Easy question again. In fact, it's so easy that I'm just going to rip through it pretty quick. I could do either way. Oh, I shouldn't do this, should I? Why is adding 3.2x not the best thing? It's not the least amount. So I'm going to get rid of the least amount like I told you I would. I'm a man of my word. 4.9 is equal to, and the reason why it's good here is what you end up with is a positive coefficient, as opposed to the other way, I'd end up with a negative coefficient. That's going to be 2.9 x, minus 3.8. Get rid of your constant. 2.9x is equal to 8.7. I think I see a repeating decimal coming on here. Am I wrong? Or is it, oh no, it isn't. It's a terminating decimal. Because there's exactly 3 of them in there, isn't there? Am I wrong? 8.7 divided by 2.9 is 3. Green giant. X equals 3. Okay, I'm going to press pause here. I'm going to let everyone right here try and rewrite this statement. That's all I want you to do. I want you to take 10 seconds. And I want you to rewrite the statement before I tell you what it is. All right, here we go. Okay, so if you think about 4, well, 4 is going to stay 4. And all I want to think about is, what is 3/5 x really? Well, 3/5 x is really 3/5 multiplied by x, or 3/5 multiplied by x over 1. Multiply the numbers, you get 3x. Multiply the numbers, you get 5. So it's really the same thing as 3x over 5. It's the same thing. Now the next one gets complicated. So negative 1 2/5 is the same thing as, x is the same thing as negative 7/5 x, which is the same thing as negative 7x over 5. Okay? Minus 1. Now, options. What would I do next? I'm a pretty bright guy. What do you think I'm going to do? I'm going to multiply both sides by 5. Right? So I'm going to multiply this side by 5, and the reason why is it's a common multiple of all the denominators in the equation. And I'm going to get 20 plus 3x equals negative 7x minus 5. I did that pretty quick, but I think if you work it out, you'll still see that it works out to be that, using distributive property. And this is much easier to work out because there's no fractions. I'm going to add 7x to both sides. 20 plus 10x equals negative 5. I'm going to subtract the constant because I'm isolating the variable. 10x equals negative 25. Dividez-vous by 10, and x equals negative 2.5. Now, since it was fractions, my apologies, I can't write it as a decimal. I must keep it as a fraction, and x equals negative 2.5. So one of the things you have to realize is one of the students said he did it a completely different way. There's lots of students who probably did this first, right? You could have done that. You could have added 1 2/5 x to each side, right? You could have done that. The way I just showed you here was the most efficient way, right? The easiest, in my opinion, the easiest way to solve it. But it's up to you. There's different ways to go. As long as whatever you do to one side, you do to the other, you'll always be able to get the right answer. This next question, which is not 6, is distributive property. What I advise you to do is expand first. So 2x minus 0.2 is equal to 0.9 minus 3x. Add 3x to both sides, because that's the one that has the least amount of it on. 5x minus 0.2 is equal to 0.9. Add it to tenths to both sides. And 5x equals 1.1. And divide both sides by 5. 1.1 divided by 5 is 0.22. X equals 0.22. Okay, looks complicated. Let's think about expanding it. What is a half multiplied by x plus 1? So it's a half times x. That's a half times 1. What will that give us? It'll give us x over 2 plus a half equals x over 3 minus 1/3. Am I wrong? Sorry, let me do this one here for you. A third times x and a third times -1 would be -1/3 and would be x over 3. So when I expand both sides, I get that. Everyone's good with me so far? What am I going to do to both sides? Because I hate fractions. Multiply both sides by 6. 6 over 1 times x over 2 is going to be 6x over 2, or 3x. 6 over 1 multiplied by 1 over 2 is going to be 6 over 2, or 3. I'm going to fast forward here. It's going to be 2x minus 2 on the other side. If you wanted to do it, you could go 6 over 1 times x over 3. Still get 6 over 3, which is 2x, etc., etc. Now I have a much easier question. And that's your answer. You could have tried to subtract fractions and done all that stuff, but to be honest, why? Why would you ever want to do it? It's so much easier when you don't deal with fractions. Now I'm even going to skip that question. Here, we'll go on to this question. What should we do here? What would a smart person do, Rebecca? Multiply both sides by what? 6 is right. So we multiply this side by 6 and multiply this side by 6. Watch what happens. 6 over 2 becomes just a 3 over 1. And now when I multiply the numerators, it's 3 multiplied by this numerator, which means it's 3 multiplied by the numerator, which is going to be 6x minus 3 is equal to, it's this multiplied by this, or this multiplied by this, which is going to be 4x plus 4. Now, if you go back to the original question, and again, I've been harping this a little bit. If you had your choice to solve this equation or this equation, I don't think anyone would try the first one, right? It's just way too complicated. Here, if I subtract 4x from both sides, 2x minus 3 equals 4 is a grade 7 question. 2x equals 7. X equals 3.5. Or if it's a fraction, 3.5. All right, question number, whatever this is the hardest question, and people had it was most confusing. It says a jar contains 76 more pennies than nickels. How the total value of the pennies equals the total value of the nickels. So how many nickels are there? So if x equals the number of nickels, Hazel nickels, is that right? I always look wrong when I spell it. Okay. then 0.05 times x is going to be the value of the nickels. Does everyone agree? So if I write that out, if x is going to represent the number of nickels, then 0.05, which is the value of it, times the number of nickels will be the value. Now pennies is going to be x plus 76, because whatever the number of nickels is, there's 76 more pennies. So if x is the number of nickels, then x plus 76 will be the number of pennies. And if that's the number of pennies, then I'm going to take that number and multiply it by 0.01 to get the value of the pennies. So x equals the number of nickels, then 0.05 multiplied by x is going to be the value of the nickels. And if there are x nickels, then there's x plus 76 pennies. And multiplying that by 0.01 will be the value of the pennies. And then it says something very important here. The total value of the pennies equals the value of the nickels. So therefore, this expression is equal to this expression. And now we've created an algebraic equation that if I solve for it, I'll know how many nickels I have and how many pennies I have. Okay, so let's expand this first. 0.01x plus 0.01 multiplied by 76 is 0.76 equals 0.05x. Variables on both sides. So I'm going to subtract this amount of x from both sides. Leave me a 76, 0.76 over here, and 0.04x over here. I don't think I've lost anyone so far. It's pretty easy. Divide both sides by the coefficient, and x will equal 0.76 divided by 0.04 is equal to 19. So, go back to our original definitions of everything. How many nickels are there? There's 19. How many pennies are there? 19 and 76 is 95. Is 19 nickels and 95 pennies the same amount of money? Yes, it is. So therefore, your answer is, therefore, there are 19 nickels and 95 pennies. Okay, our last question says, Austin, who just transferred from South Korea, has $28.50 in savings. Sorry, $28.50, and is saving $8.75 a week. Faith has $104.75, so more than Austin has. But she is not saving. She is spending $6.50 a week. How many weeks will they have until they have the same amount of money? So the first thing we're going to do is, since this is the question, how many weeks is going to be our variable. So we think about Austin first. If he has this much money, so let's try that again. $28.50. And he is saving $8.75 a week, then 8.75 multiplied by the number of weeks, or x, will represent how much money he saves, because you're going to take the number of weeks and multiply each of those weeks by $8.75 to figure out how much he's saving. So the money he has plus the money he saves by weeks is going to be Austin. Now that is going to be the same amount of money, because we want to have that to be the same amount, as Faith. She starts off with much more money, but she is spending $6.50 a week, which means that's a negative 6.50 multiplied by x, because for every week she's going to lose $6.50. Okay, so what we've done here is we've created an equation, and in this equation we have two constants and we have two variables on both sides. So when you solve this, the easiest way to do it again is to get rid of it on the side that has the most amount, or the least amount, excuse me. Sorry, adding. So 28.5, I'll get rid of the insignificant 0 because it's not necessary in the equation, plus 15.25x will equal 104 0.75. Now, we have isolated the variable onto one side, but we still have a constant, and we still have a coefficient. So we have to get rid of the constant next, and then the coefficient. We're going to subtract 28.5 from both sides. And 15.25x is going to equal 104.75. Take away 28.5 is 76.25. And our last step will be divide both sides by the coefficient. Taking that 76.25 and dividing it by the coefficient of 15.25 gives us an answer of 5. So x equals 5. So what does this mean? This means since x is 5, therefore, in 5 weeks' time, if Austin starts saving $8.75 a week and starts with $28.50, and Faith, who has $104.75, keeps spending $6.50 a week, in exactly 5 weeks' time, they will have the same amount of money.